Okay, in this video, we are going to learn about Euclidean and space. What is Euclidean and space? Basically, when we talk about Euclidean and space, it is about the dimension. Euclidean space is the fundamental space of classical geometry. Originally, it was the three-dimensional space of Euclidean geometry, but in the modern mathematics, there are Euclidean spaces of any non-negative integer dimension, including the three-dimensional space and two-dimensional space, which it also can call as Euclidean plane. Euclidean is introduced for modeling the physical universe. Okay, so let's go to our very first definition in this topic. If n is a positive integer, then an ordered n tuple is a sequence of n real numbers a1, a2, an. The set of all ordered n tuples is called n space and is denoted by Rn. As we can see here, a1, a2, an is known as components in a vector, and it also known as n tuples. And the sequence of the n tuples is called as n space, which is denoted by r power of n. As we can see here, n shows the number of the components that it has in a vector. Okay, let me give you some example here. So, in here, we can see that there is r power of 1. It means that in a vector, it has only one component. So, when it has only one component, it means that there it only forms a real line, which is the number start from the least number to the greatest real number. And the next one is r power of 2. It means that in a vector, it has two components. If we can see here, u bar equals to u1 and u2. As it has two components, of course it will form only two axes. Of course it has two axes, which is axis x and axis y, which if we put some vector here, it will form a plane. So the next one is r power of 3, which is in a vector it has three components, which is u1, u2 and u3. When it has three components, it will form a volume. As we can see here, there is three components and then it will form a box in here. So that is the basically for our very first definition in this topic, which is Euclidean and space. Okay, in the study of three space, the symbol a1, a2, a3 can be interpreted in two geometric interpretations. For the first one, it can be interpreted as point, which is the a1, a2 and 3 will be known as coordinates. And the next one, the symbol also can interpreted with vector, which a1, a2 and a3 can be called as components. Okay, let me give some example for tree space by using vector interpretation. So here we can see that v bar equals to 1, 2 and 3. When there are three space, when it is three space, of course it has three components here. And when it has three components, of course it will be volume. So we can show the volume by doing the graph here. So actually it is the vector v right here, and then we can see here is the length, which is 2, and the length here is 1, and the height here is 3. Based on this vector, we can form this kind of shape, which is okay. The next one is Euclidean inner product. Well, it also known as dot product, but specifically for dot product, it is for vectors of 2 and 3 space, and for Euclidean inner product it is for n space. It means that it can be any real number. For example, it's like 4 space, 5 space, and so on. So what is inner product for? It is actually for to find the length of the vectors and to find the angles. So why we use the word inner product? Actually, we use the inner product um, because we have to find the product between two components of the vector. So because of this, we use the inner product. So how to find the dot product? To find the dot product, of course we have to have two vectors, which is u bar and v bar, and then to find the dot product it has to be denoted as like this, which is u vector dot v vector. So to find the dot product we have to multiply each of the components, which is u1 multiplied with v1, u2 will multiply with v2, and u3 multiplied with v3, and then we have to find the total here, and the answer will be in scalar value. So I have a question here. So what if the dot product becomes 0? When it becomes 0, it means that the both of the two vectors is orthogonal. It means that the angles between vector u and v is 90 degree. Okay, the next part is how to find the Euclidean norm or length. Euclidean norm, also known as length, which is the length between origin to its point here. So Euclidean norm also can be denoted as this kind of symbol, which is between the vector it has two line between this vector. So here is the example, which is u bar equals to 2 and 3. To find the Euclidean norm, we just need to do like this, which is 2 it has to be power of 2, and 3 it has to be power of 3, and then we have to find the total and square root. So with this we can find the Euclidean norm in units. So the next part is how to find the Euclidean distance. Euclidean distance, it means that we have the distance between two vectors, which is u and v. So we want to find the distance between these vectors. So here is an example, which is u bar and v bar, which it can be denoted as du v bar for the distance. So to find the distance, of course we have to find the difference between these components, each components. It means that u1 it has to be minus with v1, and the difference of each components, and then each difference it has to be powered by 2, power of 2, and then the total of the value it has to be square root. So with this we can find the distance between these two vectors. Actually, basically the formula of the length and also the distance is origin from the formula of theorem Pythagoras, which is we have to find the difference here and difference here, and then we have to square root of the total. So that's all for Euclidean inner product.